some more examples of the type dx by p, dy by q, dz by r. And this is the differential equation in three variables x, y, z. Okay, so there are two methods, basic two methods or rules for solving this equation. That is, find a multiplier CLMN such that LP plus NQ plus NR is equal to 0, or consider any two ratio in which the one variable get cancelled or is offset. For example, this is the example x dx divided by y square z, dy divided by x z, and dz divided by y square. And so what is the answer? Taking the first two fractions, that is, consider x dx by y square z square, dy divided by x z, and in this z variable z get cancelled. Okay, so what we have? We have x dx by y square, dy divided by x, and then after separating the variable, we have x square dx into x square dx into y square dy is equal to 0, minus y square dy is equal to 0. Okay, x square dx is equal to y square. After considering first two fractions, we have this, and then integrating x cube by 3, y cube by 3, and then multiplying by 3, we get this answer: x cube minus y cube is equal to 0. So this is the first integral solution of this differential equation. Okay, then taking first and third fraction, this and this third fraction. So what we have? We have this y square get cancelled, z square also get cancelled. Therefore, x dx is equal to dz. And then after integrating, what we have? X square by 2, z square by 2, and then by multiplying 2, we have this answer: x square minus z square is equal to C2. And therefore, these are independent and required general solution of that. Is the 1 and 2 form the general solution of the given differential equation. So while writing this problem in notebook, write this problem, answer of this problem by our regular method. That is, right, taking two fractions in the place, we take this is equal to this. Okay, so similar example: dx divided by y into z, dy divided by z into x, dz divided by x into y. So consider first two fractions, and then after cancelling z, we have this, and then integration is x square by 2 plus is equal to y square by 2 plus constant of integration, suppose c1 dash, and then multiplying by 2, we have this answer: 2c1 dash as c1. And similarly, taking first and third fractions, we get this, and there we have the answer: x square minus z square is equal to c2. And therefore 1 and 2 gives the general solution of the given differential equation. Okay, then dx by x, dy by 0, dz divided by minus x. So dy by 0 means dy is equal to 0, means dy is equal to 0, and therefore y is equal to c1 is one solution. So if the denominator is 0, then directly we have one solution from that factor. That is, dy by 0 means dy is equal to 0, and therefore after integrating both sides, we have y, dy integration of dy is y, and constant of integration, suppose c1. So this is the first solution. And then consider first and third fraction, and then we have this divided by x dx, and therefore its integration x square. I think here is minus j, so correction is at this place, right? Minus j. So x dx, okay, here is right j, dx divided by j. Correction is what? At this place, dx divided by j. So dx divided by z and dy divided by minus x, we have this x dx plus z dy, z dz is equal to 0, and then its integration is x square by 2, z square by 2 is equal to, suppose c2 dash is constant, and then multiplying by 2, and we have this answer. So 1 and 2 gives the general solution: dx divided by y square, dy divided by x square, dz divided. If the first method fails, Then I apply second method, that is the method of multipliers. So by considering the first two fractions, this dx divided by y square, dy divided by x square, because z is absent. So consider first two factors, and then we have this answer that x cube minus y cube is equal to c1. Okay, and then consider the first and third fraction. First and third fraction. So what happened? Y square get cancelled, and therefore we have the two variable only, dx x and z, because y, there is y square, the variable of y, but y square get cancelled, and then we have this answer, x cube plus 3 z raised to minus 1 means 1 by z c2. After considering first and third factor, we have this answer, and therefore 1 and 2 gives the general solution. Similarly, the next problem, considering the first two factor, we have this answer. By considering two factor, we have log y plus log z is equal to log c1, yz is equal to c1 is the first answer. And by taking first two fractions, we have, by considering last two factors, if you consider last two factors, we have this, that is second and third, and then considering first two factors, we have this dx divided by dy is equal to x square plus 2y square divided by minus x into y. It is not in variable separable form, or x dx by dy is equal to minus x square by y minus 2y. Then 2x dx divided by dy plus 2 by y x square is equal to minus 4xy. Then put x square is equal to v. So actually this is the homogeneous differential equation. This is the homogeneous function of degree 2. This is the homogeneous function of degree 2, and that is the method to solve the homogeneous differential equation. Special method to solve the homogeneous differential equation. So either apply this method, or after this substitution x square is equal to v, it is converted to linear differential equation. X square is equal to v. By substituting x square is equal to v, it converted to, so y is equal to vx, or substitute y is equal to vx. The special method is what? Substitute y is equal to vx. Then the equation converted to linear differential equation. dv by dx plus 2 by y v is equal to minus 4y. So to solve this differential equation, apply the method of homogeneous differential equation. Actually, this method is covered in the class 5.T.Y.B.Sc. So observe that and solve this equation by using that method. Okay, so I will solve this example, this problem, and the answer we will share through WhatsApp group. So either use this method, or direct substitute y is equal to vx. That is the method to solve the homogeneous differential equation. So when we say the differential equation is homogeneous differential equation, if the numerator, if we convert this equation in the form dy by dx or dx by dy, and if the numerator and denominator both are the function of same, homogeneous function of same degree, then we say the differential equation is homogeneous differential equation. So the same type problem, the answers are given. That is, all these problems are depend on the first method. That is, either one variable get cancelled or absent in two ratios. Okay, so the next rule that we find multipliers. We find multipliers. Okay, or either use the first solution to solve to find the second solution. So the sub method of the method number 1. So dx divided by this, dy divided by this, dz divided by this. Then cancelling this z square x plus y, that is considered first two ratios, and cancel this. What do we have? We have 1 by x dx minus 1 by y dy, and after integrating, what do we have? Log x plus log y is equal to log c1, that is x into y is equal to 7. That is considered the first two factors. Then the first and third fractions given, that is first, consider first fraction and third fraction, and then what do we have? And substitute this x into y as c1, x into y as c1. So consider the first and third fraction gives x raised to 4 dx xz z square, substitute this xy as c1 dz, and then what do we observe? That these two fractions, in these two fractions, y is absent, and that's why we have the integration. Its integration, the integration of x cube is x cube x raised to 4 by 4 minus z cube z raised to 4 by 4. C1 is constant, integration of z is z square by 2, and then suppose C2 dash is the constant, C2 dash, then multiply by 4, we have this, and 4 C2 dash is suppose C2, so we have this answer. So this is the actually sub method of method number 1, that is use first find the solution, first one solution by using the first method, that is by considering any two fractions in which the one variable is absent or cancelled, and then use that solution to solve the to find the another solution. Okay, so this is actually the sub method of method number 1, or it's called rule number 2. Then solve the same dx divided by x into y, dy divided by y square, dz divided by z x y minus 2x square. So consider two fractions, first two fractions, because z is absent, and then after separating the variables, we have this, and so we have x by y is equal to c1. So 1 by x integration is what? Log x log y minus log y is equal to log c1. Log x minus log y is log x by y is equal to log c1. Then cancel log, we have x by y is equal to c1. Then use this x by y as c1 in the to find the second solution. So from 1 we have x is equal to c1y. So consider second and third ratio. Consider second and third ratio. That is dy divided by this and dz divided by this. And write x in terms of y. So x get cancelled. That is substitute x as c1y. So in the by considering second and third ratio and substituting x as a c1y. And so we have this after simplification, after separating the variables, that is shift all the z variable z functions to RHS and y functions to LHS, and then integrating. So c1 dy integration is c1y minus after shifting it to right side, left side. So log z minus 2c1 square. The rule is what? 1 by ax plus b. So a is 1, z x means z, and this minus 2 c1 square is constant quantity. So log z minus 2 c1 square divided by 1. Coefficient of z is divided by 1. So is equal to c2. And this is the second solution. This is the second solution. And so 1 and 2 gives the resubstitute. After last step, resubstitute c1 as x by y. So we have log z minus 2 c1 square, that is x square by y square is equal to c2. This is the second. This is the second. And so 1 and 2. If we denote this is second and this is third, then 1 and 3 gives the general solution or complete solution of the given differential equation. So dx divided by 1, dy divided by 2, dz divided by. So consider first two ratios, two fractions, dx divided by 1 and dy divided by 2. We have this answer. Okay, and by considering first and third factor, substitute y minus 2x as c1 in the second factor. So we have the answer, and then resubstitute as c1 as y minus 2x. So this is the second one, and so 1 and 2 gives the general solution. Similarly, the third problem. So these are the problems on the subtype of the type number method number 1. That is find first solution by considering two ratios and then use the first solution to obtain the second solution. Then dx divided by y, dy divided by dx. Consider first two fractions, we have this answer. X square minus y square is equal to c1. Substitute x square minus y square as c1. And consider the first and third fraction. And we have this. And after integration, separating the variable, we have this. And integrating. So x square by 2. And the integration multiply by 2, or then find first integration and then multiply by 2. We have this answer. Okay. Z raised to minus 2, integration is z raised to minus 2, integration is z raised to minus 2 plus 1 divided by minus 2 plus 1. That is z raised to minus 1 divided by minus 1. That minus minus become plus sign. Okay. So these 1 and 2 forms the general solution of the given differential equation. Then similar example, dx divided by x into z, dy divided by y into z, dz divided by x into y. Consider first two fraction. We have x by y is equal to c1 as the first solution. And then consider the second and third fraction. Second and third. And in order to cancel this x, substitute x as y c1y, x as c1y. So substitute x as c1y, c1y, and then we have this. And after solving, after integrating, we have this answer. Okay, and then resubstitute this c1 as x by y into y square minus z square is equal to c2, and this is what equation number 2, and then 1 and 2 form the general solution or complete integral of the given differential equation. A similar problem. So by considering first two factor, we have this x into y is c1, and you use that x into, then consider last two fractions, dy divided by y cube and dz divided by axz, and to cancel the x, substitute x as c1 by y, because if you consider dy and dz, then cancel x. So x, in order to cancel x, use the first solution, that x is equal to c1 by y, and then separate the variables, and integrating we have this answer, this solution log z. After resubstituting c1, after integration, resubstitute c1 as x into y, c1 as x into y. Yeah, this c1 as x into y. We have this answer, and 1 and 2 gives the general solution of the given differential equation. Okay, so solve these problems, exercise problems, and these are again depend on the sub method. These are of this type, that is sub method of the method number 1. That is first find the solution. Here is the variable are dx, dt, dz. That is the answer is what in terms of so correction is that it is not dt, it is dy, right? Dy by minus 2. So solve these examples by using the sub method of method number 1. That is find first solution by deleting or considering any two fractions, and use that solution to obtain the second solution of the differential equation. Then here is the method of multipliers. Okay, that is find multipliers LMN such that LP plus NQ plus NR is equal to 0. Find multipliers LMN. Okay, that is LMN are the either constants or functions of x, y, z. So the first example, a dx divided by b minus c y z, and this b dy divided by this quantity, c dz divided by this quantity. Okay, and then choose multipliers x, y, z. So each fraction is equal to, or each ratio is equal to, right? The first sentence that choose multipliers x, y, z, then each fraction or each ratio is equal to a, that is multiplied by x, the first fraction by x, then y, and then z. So a x dx, numerator is what? A x dx plus b y dy plus c z dz divided by, multiply by x, what do we have? B minus c x y z, then plus c minus a x y z, and plus a minus b x y z. So if we take x y z as common, then we have b minus c plus c minus a plus a minus b, and it is equal to 0. So choose multipliers element such that LP plus NQ plus NR is equal to 0. So we have the answer 0, and therefore AX plus AX dx plus BY dy plus CZ dz is equal to 0. That is numerator is 0. And then integrating, so integration of x is x square by 2, y square by 2, z square by 2, multiply by 2, we have this answer, that ax square plus by square plus cz square is equal to c1. C1 is the arbitrary constant, and this is equation number 1 or solution number 1. Okay, so this is the problems on the method number 2. Okay, and then another solution, to obtain the another solution, choose the multipliers ax plus by, ax by and cz. So these are the multipliers ax by cz. So each ratio is equal to, or each fraction is equal to, that and multiply by ax to first fraction. We have a square x dx plus b square y dy plus c square z dz divided by, multiply by ax plus by plus cz, and we have the answer 0. And therefore a square x dx plus b square y dy plus c square z dz is equal to 0. So these are the factors linearly independent with respect to the first three factors, these multipliers. So we have the answer after integration. We have the answer a square x square plus b square y square plus c square z square is equal to C2, and this is second. And then 1 and 2 gives the general solution of the, or complete integral of the, or complete solution of the given differential equation. Then next example of the same type, dx divided by this quantity, dy divided by this, dz divided by this. Then choose the multipliers x minus y minus z. So by using trial and error method, find these multipliers such that LP plus NQ plus NR is equal to 0. So if each ratio is equal to x dx minus y dy minus z dz divided by, multiply this by x, so we have this and quantity, plus multiply this by minus y, so we have this, and minus z, we have this. And if we simplify the denominator, we have the answer 0, and therefore x dx minus y dy minus z dz is equal to 0. And after integration, we have this answer. After integration and multiplying by 2, we have this answer, and this is equation number, solution number 1. And then using multipliers y, x and minus z. So this set and the previous set of multipliers, these are linearly independent. So each ratio is equal to y dx plus x dy minus z dz, and multiply by y, x and minus z, and adding we have the answer 0. And then y dx plus x dy. So it is the derivative of x into y. So write dx, d in bracket x into y, the value of, so multiply by 2, or directly find integration. Say, so it is dx into y, and d, then integration of z is what? Z square by 2. So what we have the answer? X into y, z square by 2. And then after multiplying by 2, we have this answer. Okay. So, and then 1 and 2 gives the general solution or complete solution of the given differential equation. Then this problem, use multipliers LMN, we have the answer 0, and therefore after integration we have this answer Lx plus My plus Nz is equal to C1. And then choose multipliers XYZ, again we have the answer 0, and so we have the second solution as x square plus y square plus z square is equal to C2. The next problem, already these problems are solved in previous lecture. So use multipliers x, y, z. Here 1 by x, 1 by y, 1 by z. Or these problem multipliers are ABC, AB1 are the multipliers. dx divided by y, dy divided by minus x, dz divided by bx minus 7. So we have the answer denominator 0, and so we have this is equal to, and after integration we have this is the solution. A x, integration of dx is x, dy is y, dz is z is equal to C1. Suppose this is number 1. Then by considering first two fractions, that is z is absent in first two fractions, and after integration we have x square plus y square is equal to C2 as second. So this example is first solution is solved by using method number 2, and the second solution is obtained by using method number 1. So the combination of the two methods for this problem, so 1 and 2 gives the general solution of the given differential equation. Then this is the problem number 6, that choose multipliers 1 yz, we have the answer. And from last two fractions, because x is x is absent in the last two fractions, and so after integration we have this as the answer. Next problem, problem number 7, the multipliers are 1 by x, 1 by y, and 1 by 3z. So usually the multipliers are what? X, y, z, 1 by x, 1 by y, 1 by z. So these are the multipliers. So by using trial and error method, find these multipliers, and then we have this answer as a equation number 1. solution number 1. Then consider first two fractions. First two fractions, because z is absent in first two fractions. So after separating the variables and integrating, we have this answer. Next, problem number 8. Again, the same type. Use multipliers x square, y square, and minus 2 by z square. So each ratio is equal to, this answer is 0. And then we have, after integration, we have this answer. And first two, if you consider first two fractions, z is absent, we have this answer, x cube minus y cube is equal to 7, and 1 and 2 gives the general solution. Then problem number 9, multipliers are 1 by x, 1 by y, 1 by z. And the second set of multipliers is what? X, y minus 1. So solve this problem. Only write this A number, problem number A. Don't write this problem number B, 10B. Okay. So multipliers are what? 1, 1, 1 and x, y, z. These are the two sets of multipliers. For the problem number 11, the multipliers are 1, 1, 1 and 1 by yz, 1 by zx, 1 by x into y. So these are the two sets of multipliers. For the problem number 12, the multipliers are x, y, z and 1 by x minus 1 by y minus 1 by z. So if you observe the problems, the multipliers are x, y, z, 1 by x, 1 by y, 1 by z, or x minus y minus z. So next problem number 13 is multipliers are x minus y z, and the other set is what? Y, x and minus 1. So this is the other set of multipliers. Next problem number 14, the multipliers are 1 by x minus 1 by y and c1 by n, c1 by n. And by considering first two fractions, we have one solution, and by using the multipliers 1 by x minus 1 by y, c1 by n, we have the another solution, second number solution. And then first and second gives the general solution of the given differential equation. Then problem number 15, by taking last two fractions, we have this answer, y by z is equal to c1 as first solution. Then multipliers are x, y, z. We have the answer, x square plus y square plus z square is equal to c2. And then 1 and 2 gives the general solution. Then problem number 16, multipliers are 1 by x, 1 by y, 2 by z. So there is a change, that 1 by, in the place of 1 by z, it is 2 by z. So, and then multipliers are x cube, y cube, z cube. This is the another set of multipliers. So we have this solution, x square, x raised to 4 plus y raised to 4 plus z raised to 4 is equal to c2. Sometimes multipliers are chosen by using a trial method, trial and error method. The whole procedure is explained in the next example, example number 17. That is choose multipliers LMN. So choosing LMN, so what we have, answer is 0, and therefore the multipliers, how we can find 2 minus 3 minus 4 as a, that is randomly we choose the multipliers LMN. And how we can find the values of LMN? So we have multiply by L with P, M by with N, and N by N with R, and then we have this equation. And in order to satisfy this equation, the coefficient of x must be 0, coefficient of y must be 0, and coefficient of z must be 0. When this is equal to 0, then we have these three equations. And after solving these three equations for LMN, we have the answer of L is 2, M is minus 3, and N is minus 4. And then choose multipliers as 2 minus 3 minus 4. So how we can find the multipliers LMN, constant multipliers? By using this process, we can find the multipliers 2 minus 3 minus 4, or by using trial and error method. And then we have this solution number 1, x square minus y square minus z square is equal to c2. Then solve this example. From last two fractions, we have this answer. And choose multipliers 1, y and z. We have the answer 2x plus y square plus z square is equal to c2. Okay. So similarly, example number 19, 20, 21, 22, 23, 24, and solve these exercise problems. So we'll see remaining problem in next lecture.